Thank you, everyone. I hope you are having a wonderful day. And if you have attended the previous session, this will be almost similar, but I have a few more contents. I have not seen Jess's deck yet, but bear with me and see how this goes. I have some cool use cases, some cool demos, which I've been working for the last couple of months. So we'll go through that. So everybody is using EDA today with serverless, with containers. Who's using event-driven with containers? Okay, one hand. Okay, good. As a way of introduction, just to quickly, okay. My name is Dhiraj Mahapatro, and I'm a principal serverless specialist SA, and I focus on financial services customers. I started as a Java developer a couple of years ago, and if you go and find me as a Groovy and Grails SME in Stack Overflow, you will find me today as well as a top 3 users to answer questions on Groovy and Grails. So Groovy and Grails has been my past life. And I extensively am working on building EDA solutions or use cases for industries, mainly financial services. Java on serverless. Anybody doing Java on AWS Lambda? Okay. Yeah, if you have questions, awesome. If you have questions, let me know. Lambda Snapstart, Java on serverless, and then Gen AI on serverless. And I had a session before. If you want to reach out to me, you can please follow me in LinkedIn or Twitter. Today we are going to cover, and I think this is not something new, like why use event-driven architecture, but the most important part will be the demo and the industry use cases with container workload, right? That's what I want you to take away from here to see how extensible event-driven architectures are. And it doesn't matter which compute that you choose, you should be able to expand or evolve from your current solution. And then a couple of notes on how to get started. So in general, why do we want to use event-driven architecture? It is not something new, right? It's not a new concept. We have been talking about domain-driven design, event-driven architectures way long ago. And why are we talking about it today? Because the new thing that has happened is cloud and becoming cloud native. How do you do event-driven architecture, becoming cloud native, and how cloud native solutions provide the facilities or facilitates you to become event-driven much more faster. In early days or previous years, we used to set up clusters for Kafka, you have to set up for MQ, and a lot of things has to happen for you to actually get the value of event-driven architecture. But that is not the case right now. You can become event-driven right at the get-go. Excuse me. But before we understand how event-driven architecture works in AWS in a cloud-native way, let's take a few minutes to visualize an insurance claims processing system and how would it look like if you have to build it in a traditional architecture, right? We have a producer, which is the claim service, and there are multiple consumers that the claim service has to use to actually work on a claim, on an insurance claim. Those consumers can be document service, the settlement service, or fraud service. So if we go with the traditional approach of synchronously invoking those services from claims, you will deal with some good things and some bad things. So what are the problems that we see with this architecture is basically the tight coupling between producers and consumers, right? If claim service has to depend on the benefits that it gets from all the other consumers, and if document service suddenly goes from 100 millisecond response time to 700 milliseconds, claim service cannot do anything. It has to slow down. The entire performance of the application goes down. There are multiple point of failures. If you don't implement a retry logic, or if you don't implement, let's say, a short-circuiting capability in claim service, if settlement service fails, then there is a chance claim service will raise its hands up and it will fail and send a nasty response to the customer. Slowly, you get varying degrees of quality of services, as I mentioned earlier, right? If one service slows down, the entire services is affected. And then external dependencies will keep on adding. Right now, you see 3 boxes in the right. It can be 5, 10, 15, and you keep on degrading the application. So at the end of the day, the client experience will go down. Excuse me. What event-driven architecture helps you to do is to understand one basic thing. Like, we can live without synchronicity. We can have something asynchronous possible and make our application grow and behave in a certain way that is useful for our end client. So if I take the same architecture from the previous slide and talk about what we have right now, is the introduction of an event router or event broker. We introduced event broker in between producers and consumers. So we broke the synchronicity at that point. We are relying on asynchronous nature of this entire architecture. So why did we bring that event broker in place? The major benefit of decoupling a producer and a consumer is that you can have fine-grained control over things. Now the claim service doesn't have to know which service it has to call. So you are breaking the temporal coupling right there. So claim service will just can say, okay, a claim has been requested, go do whatever you want, it's your downstream services. In future, if there are 5 or 10 more boxes that gets added in the right, the claim service doesn't have to care. Not the other consumers also don't have to care whether there are 5 boxes or 10 boxes in the right. You get buffering capability if you can implement some queuing mechanism in the consumer side, so that when events come in from claims, it doesn't overwhelm document service or fraud service or settlement service. And finally, now you'll be thinking, okay, with synchronous APIs, we were getting responses back immediately. That's true, but we have mechanisms that can send response back from the event router via notification service. And we have different mechanisms, like it's a different topic altogether, but in brief, it can be WebSockets, or you can poll, or you can build something with IoT core topics. So at the end of the day, the customer will get a good experience. On top of that, you evolve this architecture in a way that you can plug in a new producer or a new consumer without affecting the entire system. Now that is where you see the reliability, the resiliency, and the independently scalable components that you just built that can help your business. So if you go to the whiteboard and think about what event-driven architecture should look like, what are the core components? The first and foremost thing is thinking asynchronously, right? You have to start thinking asynchronously because events are always asynchronous in nature. You think about event routers. Event routers excuse me, are responsible for decoupling producers from consumers. And with event router, you get the capability of independent scaling in place. And then we have event stores. Like, why do we need event stores if we have event routers? Your claim service can start pushing messages in a really drastic way, which your document service is not able to handle. So you need some store in front that can handle that incoming traffic, and you can scale document service at its own pace. So that's why you think about event stores. Another major component to look at, another major definition to look at, is the degrees of freedom that you get when you think about asynchronous and event-driven architecture. If you think about directed commands, like with synchronous way, you would ask, for an example, please send an email confirmation, and then that person or entity has to wait until the email confirmation is sent, right? And then once the email is sent by the different entity, okay, it is sent, then the first entity has to move forward. So there is very low degree of freedom. On the contrary, if you look at events, events are observable. So you gain higher degrees of freedom. If a customer X has just filed a claim, then the claim domain can send, okay, the claim has been requested or has been filed, then simultaneously multiple consumers can start acting on top of it, right? So one can say, I will verify the policy details. Other one can say, okay, let's go through the uploaded documents. Another entity can say, okay, let's see what are the notifications that we need to send to the customer. Tomorrow, if I want to implement fraud service, I can add that fraud service without any problem. And that fraud service can become an additional consumer that can help with handling fraud without affecting the claim service or the other consumers. So now that we talked about insurance claims as an example, let's dive deeper into that use case. So insurance claims processing. Anybody from insurance domain? Okay, great. So you already know, please forgive me if I have to repeat the same. Just for brevity, I'm going through what actually insurance claims processing is. So before you file for insurance, you have to sign up for insurance, right? Any kind of insurance. So you get a quote from different providers or different insurers. You figure out what's best for you, and then you provide some information from your side, like a driver's license, or optionally you can provide an image of your car, and then you sign up for your insurance. However, insurance actually comes into work when you're filing a claim over the period of time. When you're actually having an insurance, and the reason of you have an insurance in the first place is to handle the worst case scenarios in life. And you want to handle those worst case scenarios as swiftly as possible and as fast as possible, right? So let's say but anybody is driving on a fine day and they met with an accident. So once they gather themselves and they are okay to start the claims process, they can get information about the damaged car, and ultimately they file a claim. And this process in general is the handoff process, is called first notice of loss, or in short, it is called FNOL. And everybody, from insurance domain, they know what FNOL is. So whenever I say FNOL, it's first notice of loss, saying that, okay, I lost something, and this is my notice to you, and start working on my claim. Let's look at an application that actually showcases what this is. So I have built an insurance claims processing application sample where I have incorporated like authentication and authorization. I already have an account. So I sign up. I sign into this account, but I have not onboarded as a customer yet. So I was just allowed to get into their application. So now that I'm in their application, let me maximize that a little bit. This is good? Okay. Now that I am in their application and I want to actually onboard, so I have to provide multiple information. So here is a form that you see. It doesn't have to be this form. It can be something very proactive, and it can be done via your phone communication or via an iPhone app or any device apps. But just for simplicity, I've used a form. And you provide your information, you provide make and model of your car, the color of your car, and the type, mileage, and some VIN information, right? Now you want to onboard that as a customer, and while you are providing this information, you provided a wrong information about your SSN. So let's submit and see what happens. So right away, you get a notification saying that your address or identity is invalid. And you get that as an event back. So the event that received from the backend services says that, okay, immediately your address or identity information is bad. So now that you fix it and go ahead and submit, you should be able to move forward, and you get a customer accepted event. So I'm getting events back from the system, and we'll see how does it work behind the scenes. But at this point of time, I'm getting a customer event back saying that, okay, the customer is accepted. And let's say I have to provide a driver's license information, and then I upload a driver's license. That has to be uploaded, and something has to happen in the background. And this time when I uploaded the driver's license, it processed the document successfully, but it immediately figured out that there is a fraud happening, because in the form I used a first name, last name that doesn't match with the first and last name that is present in the driver's license, right? So I did not ask as a consumer, I did not ask, go and check for fraud, but something happened behind the scenes, and it did document processing, and it did the fraud checking for me. Now let's fix that, Okay, let's say you have the right driver's license now and you upload it. So you will see again a document processing happening. So a document processed event comes back saying that, okay, your driver's license are processed successfully, and this time there was no fraud detected. Now let's go and upload an image of your car. If I choose a color of a car which did not match with the form that I previously provided, it will again do the same thing, fraud detection. So right now I have used the color as green, so let's go ahead and use a green color image and upload. So you should see the document processing event always comes up as and when I type or upload a driver's license or a car image. So as soon as document processing happens, fraud wakes up and checks whether any fraud is happening or not. This time there is no fraud. So now that you have onboarded as a customer, assume that sometime in future that you have to file a claim. And then again, you provide all those information that you need, or the description, the other party's insurance information, your driver's license, etc., and you submit a claim. Now when you submit a claim, the same process happens, figures out whether it's a valid claim or not, and then a claim is accepted or rejected. In this case, it is accepted because all of the information I provided was good enough. Again, if I choose a damaged car to upload, and if I use a car that doesn't have a damage or it doesn't match with the color that I have in my policy, you can trigger a fraud notification. But let's go with the green car that is damaged and upload it. So if you see, constantly I call document processing. Every time I upload something, a document gets processed. But at the same time, something happened pretty rapidly. That is, like when I process the document, it figured out the color of the car is green. It figured out that the damage is a bumper dent. And this is not hard-coded actually. This is coming from recognition custom label. It figures out the image of the car and checks what is the color of the car and whether it has a dent or whether it has some other problem. Once the fraud is not detected at this point of time, you can see different other domains actually started working independently. You saw these two cards, settlement finalized and vendor finalized, immediately popped up. Right? So settlement finalized is a different domain that was looking for fraud not detected, and then immediately kicked off and figured out, okay, based on the analysis, we can settle it for $100 out of pocket for you. As soon as settlement finalized event comes in, vendor service wakes up and tries to find a rental car vendor for you while your car is being fixed. So all those events that came in from different domain. Now let's see how actually it works behind the scenes. So what we saw is different APIs, sign up API and then FNOL API for filing the claim. We have document service for processing documents and different other business domains in the right hand side marked as blue boxes. So the first thing that we saw was a sign up API. That is where we did a API call, HTTP API call to sign up. And once we signed up, that customer API call became a customer submitted event, and we have the event broker in between that routed the customer submitted event to the particular domain called customer service based on a rule. We'll talk about what that is. Now once customer is accepted, that event is again sent back to the broker, and there is a rule that is defined in the broker that anytime any event comes as customer accepted or rejected, notification service has to pick that up and send it back to the customer. Now after we signed up, I uploaded an image of my driver's license and car. Again, that converted to an event, what is object created event from S3 bucket. That's where document service kicked off. And then it started working on the document, and document is processed. You'll see the document processed event went at the same time to notification service as well as to the fraud service. You didn't control that. Asynchronously, it happened. So now fraud service is interested every time a document gets processed. I need to wake up and I need to figure out if there is any document fraud happening or not. So this time when the document was processed, there was some fraud detected because we used the wrong driver's license. Now that we fixed it, let's move on to the next step. The next step is we went and did a FNOL call, like a claims processing, like initiate the claim. The same thing happened. The claim requested event gets transformed to an event broker, and then that request gets to a claim service based on a rule, and then the notification went back to the browser, in this case the client, which says claim is accepted. Then we uploaded a damage car document, the same process of document processing, like object created event, and document service actually worked on that event, and document processed. Now fraud kicked off. Fraud is, this time there was no fraud detected. As soon as the fraud was not detected, settlement service woke up and wanted to settle the whole claim. What you didn't see here is how vendor service wakes up. As soon as settlement finalized, event comes in, vendor service can subscribe to that event and finalize the vendor. This QR code is to a blog that explains each domain, and it is a 3-part series blog, but you can start from this and you can learn how. The third part is one which is very crucial to our discussion today. Okay, so let's talk about the event broker a little bit. In this sample application that I showed you, I have used Amazon Event Bridge as the event broker. So as we know, Amazon Event Bridge provides you the capability to decouple producers from consumer by creating your own custom event buses for your domain if you want to, and if you don't want to use the default event bus. And then you have multiple services on the left that can integrate with or push events to Event Bridge custom event bus. You have multiple rules that you can define in your Event Bridge custom event bus, and then you can trigger some targets. So those event sources can be your actual application. Like for me, it was the front-end application that, or the application which was hosting the sign-up API or FNOL API that was converting the incoming payload to an event object and pushing it to the event broker. And then inside my event bridge, I have a custom event bus called claims processing bus that was picking up, and I have different rules. If I get a customer submitted event, I have a target that goes and calls customer service. If I have a claims requested event, I have a target that goes and calls claims service. So, and my targets can be anything. So let's look at how event-driven across compute happens. So if I dive deeper one level down and look at the claim service part, when an FNOL API got called and claim requested event is delivered to the event bus, I have a rule that triggers claim service. In claim service, I have SQ in the front. And it makes perfect sense to put an queue in claim service, because in an event, let's say there is icing on the road, or there is a catastrophe like earthquake or flooding, suddenly you will get like a spike of events or claim requests. You don't want the underlying Lambda function or the underlying business logic to get overwhelmed. That's why the SQS makes more sense here. So you put this event store, and Lambda function behind the scene can actually pull from that SQS queue and work on it. What is Lambda function? It's pretty basic. I think throughout the day you have heard about it a lot. It's just a function as a service. You provide your business logic. You can trigger that function based on an event. And then once your Lambda function is triggered, you can have business logic that can integrate with other services too. It can be S3 buckets, DynamoDB database, or any AI/ML endpoints. Then let's dive deeper into document service. In document service, I had event-driven setup with step functions. Anytime you uploaded an image for policies, like your driver's license or car, it got updated to a bucket, and then that triggered an event to the default event bus. Document service state machine was looking for that event and then it worked on it, figured out if it is a driver's license or a car. If it is a driver's license, go to textract and give me a structured data of driver's license. If it is a car image, you go to recognition custom labels and give me the color of the car, or if they have any damages or not. And then ultimately, document service publishes an event back to the custom event bus. So this is the state machine that looks like how it did with the document service. You must have heard this step functions all across throughout the day today. On a brief note, it's actually a resilient workflow automation service available in AWS. The good part with AWS step functions is that you can declaratively define how your workflow should do or should work. You can have error handling that is built in, and you can just declaratively provide what should be my error handling strategy, and then you can keep on going. You have AWS integration, auditable history, and so forth. Then let's dive deeper on the settlement service. So this is the third part of the blog I was talking about. This actually talks about how you can bring container workloads. So let's assume for a second that settlement service is something that we added later to this whole setup. And the settlement service domain or the team has built settlement service using ECS Fargate, using a Spring Boot application, and they are having an API gateway at this point. So they have an API endpoint, and any microservices interaction has to happen through API endpoint. So, but the requirement is that settlement service now has to integrate with what we have today as an event-driven architecture. So the way it can be easily done without any major change in code in settlement service is when you bring in the event publisher side, and when you show that fraud service has fraud not detected event set up or it has emitted, that event can be picked up by Amazon Event Bridge, and the existing endpoint for settlement service can be invoked from Event Bridge as an API destination. So the only change you have to do at the end of the day is somewhere in the AWS Fargate service or your Spring Boot application, you have to emit an event back saying that settlement has been finalized. Everything else stays the same. So this is one of the good way to reuse what you have today without rewriting majority of your code in existing domains. Then let's talk about the underlying compute what we have. So AWS Fargate on Amazon ECS provides you this capability. If you're using Fargate, this sample application that I showed you uses Spring Boot application on ECS Fargate, and I was able to run it without thinking about provisioning any instances, no thought process behind container upgrades, etc. And I actually have used Spot and Graviton savings as well in the sample application. So you get all those niceties when you're using ECS Fargate. Now let's talk about vendor service. Who is using EKS today? In the organization, anybody using EKS? So you will love this. This is not limited to ECS Fargate or Lambda function. You can be event driven with EKS. So assume the same scenario with settlement service what we had. You think of vendor service, which takes an API call, it fans out to different rental car companies and figures out what is the best code, gets back the information, and figures out which rental car company should serve the request for this particular claim. It is an endpoint as of today. How do we integrate that with a new event-driven architecture? This is another pattern. So you got an event to event bus, which is settlement finalized. Now settlement finalized event can have an SQS as the target, and then you will see a small icon here called Keda that can run on your EKS cluster that can look for those events or the messages in the SQS queue and then scale your application running on EKS, right? And then you can do the same thing. You can emit events back as vendor finalized. So what is Keda? So you can go to this their website keda.sh. It's a Kubernetes event-driven auto-scaling. It's you can easily start with Keda if you are thinking about event-driven applications. So you can scale containers in Kubernetes or Amazon EKS. It's fully event-driven. The reason I say fully event-driven is because you want your applications running on EKS, your deployments running on EKS to scale based on the events that you have instead of the CPU capacity or the CPU requirements or the HTTP requirements, API calls coming in. So now that we are not looking at HTTP API calls, we are looking at an SQS where EKS application has to pull from. Keda gives a nice feature called scalars. They are built in Keda, and you can define that as a scalar. You can define SQS as a scalar and say that if my queue length in SQS goes above 5, I want to scale my deployments this way. Make sense? Okay. So there are different AWS services support available in Keda. You have SQS, you have Kinesis data streams, you have DynamoDB, you have DynamoDB streams. So if you have existing applications running on EKS or Kubernetes in general, and you want to integrate with AWS Cloud Native services that are event-driven, this is a really good mechanism for you to scale your applications. I built this application using EKS and Keda and AWS CDK. If you know CDK, anybody using CDK? Okay, it's a cloud development kit where you can define infrastructure as code written in the language of your choice. So I chose TypeScript. What I have here on the top is the cluster created already, and then I am adding Keda as a Helm chart to the cluster, and then I define the scaled object that Keda needs. The kind is scaled object, and then I make sure that what I want to scale, it's a Kubernetes deployment I want to scale, and on what trigger I want to scale. In this case, the trigger is SQS, and I want to scale this based on the queue depth of the queue that I have integrated with, right? And then if I want any authentication that Keda has to use, by default, I believe it uses the pod's identity owner. You can change that and move to something else. So what are the benefits that we see when we choose architectures like this using event-driven, right? So first of all, we saw that it's an extensible architecture. This is what I had like at least 2 months ago with settlement service running on ECS Fargate and everything else. It took me less than 2 days, assuming that I did not work 8 hours a day, to add vendor service to this whole setup without touching any other service. I was able to add vendor service which runs on EKS without touching any other service. That's a huge thing, right? Think about your testing cycle. Think about if something fails in vendor service. You don't have to worry about whether it affects my document service or whether it affects my customer service, etc. So that is a very powerful feature. You have to be very cognizant of how this can actually be very powerful going forward in your applications. It facilitates polyglot architecture also, right? If you have different teams and those teams, they want to use different languages of choice for different domains, they can very well use, because what we are talking about, your language between those teams is events. You give me event of type this with this schema, I can subscribe to event of type this schema. So when you treat events as your first-class citizen, you rely on a language, you rely on a schema, then the underlying language of choice, be it Java, .NET, or TypeScript, or Python, doesn't matter. You can have this integration very cohesive. Insurance domain sees third-party integration a lot. So if you have seen third-party integrations coming up a lot, the same way we added ECS Fargate service with API destination, Amazon Event Bridge API destination can be used to integrate with third-party services that are outside of AWS, right? So you call an API destination, which the API that the third-party service has provided, and then you provide a webhook. Right now, you can provide an API gateway endpoint as a webhook, which they will call once they're done with their work, and you can convert that API gateway endpoint, the payload that comes in, to a put event and put it back into the system that you already know. So now you are converting HTTP request back into the event, and once it is converted to an event and you put that in Event Bridge, you are back in the game, the whole system. So what are the major takeaways if you want to look at? It's a very extensible architecture. If I want to build 2 more services in addition to vendor service, it'll take drastically less time for me to build. So highly extensible architecture based on events. Polyglot implementation, because different teams, you don't have to fight for it has to be Java, it has to be Rust, it has to be something else. It doesn't matter as long as you publish and subscribe events. You can orchestrate whenever necessary. Like in this case, I'm orchestrating using step functions for document service. And I can extend this to include new features, like I just talked about generative AI and serverless. If I want to extend this document processing to involve or add any generative AI specific components, I can do that very easily without affecting customer service or without affecting fraud service or none of the other consumers. And then it did not matter whether I choose Lambda as the compute or ECS Fargate or EKS. So you have seamlessly integrate with the existing workload. If you don't have the need to recreate what settlement service is doing today or vendor service is doing today, you can just bring those workloads closer to this EDA setup by just making sure that these API destinations and events are being consumed by using something like Keda. Last but not the least, and this is the most important part, is that we have reduced the area of impact, right? So when you reduce the area of impact, it means that when I added vendor service, it did not affect any other system, which means I can do a lot with that capability. I can have multiple teams running or working simultaneously that can add stuff to this setup without drastically affecting it. Some of the other EDA patterns with containers you can see on AWS is like how do you want to orchestrate containers for large scale data processing, right? Let's say you have documents and document gets uploaded to Amazon S3, which triggers an event to EventBridge, and then EventBridge triggers a step function where you want to pre-process something, and then you want to call an existing service where you are already processing some data. And that service might be running on Amazon EKS. Again, the Keda story comes into picture. You can use Keda to scale. Now, I have used SQS as the mechanism there and as well as here. In this case, SQS is used inside the state machine. As and when I push events to SQS using a distributed map in step functions, Keda can help scale the run job, the process run job running on EKS. Now I've used one of the capability of step functions called wait for task token, where I'm waiting, the state function, step function will wait until the process run job is complete. The process run job sends a task success, and then it moves on to the next step. The next step is, again, if you have an existing system running on EKS, you can do the same thing for like reconciling everything that you built earlier using distributed map, and then put it in a different S3 bucket or send a response. So how can the other one of the pattern is ECS tasks that are triggered as an EventBridge rule target. You can have a single ECS task invoked based on a schedule, right? So if you have a task, you have EventBridge scheduler, you can directly schedule run this task at 9 a.m. or 9 p.m. You can have ECS task triggered. Not just a single task, you can have multiple tasks triggered using scheduler, EventBridge scheduler. The difference here is you have to send that event to a default event bus and define a rule that can fan out to multiple ECS tasks that can do 2 different or 3 different jobs for you. Let's talk about streams and queues triggering and scaling Amazon EKS deployments. So we saw the queue example in both the cases, but you can also do the same thing with DynamoDB streams. And this is how the triggers will look like in your Keda scaled objects. You have to define the type, and you have to define the metadata where it asks for the table name and the shard count. So these are the deciding factor for how you want to scale your Kubernetes deployments. Same with Kinesis data streams, all you need to do is change the trigger type to Amazon Kinesis streams, and you define the shard count, define the region where the stream is present, and the stream name. This is something we just saw with SQSQ. So all it matters is the power you get is the declarative way to figure out which event source that you want to use and define that as a trigger if you want to use Keda on your EKS. We saw this example as well, like we have events to private endpoints, like in the settlement service example, you have event bridge calling an API endpoint, and you have private resources or applications running in your private subnet. There are existing patterns that are available when you're using ECS with AWS CDK, and those patterns will help you to actually build the scaling capability based on whichever event source that you choose. So if you take the example of SQS and Amazon ECS, you have this queue processing Fargate service as a construct, as a CDK construct that allows you to create a L3 construct, and then you can scale based on the approximate number of messages that are visible in the queue. That's a metric that SQS provides you. And then you can distribute between using on-demand or spot, Fargate spot or Fargate on-demand. So these are some niceties as a pattern that is available for you. Now this is my favorite part. Anybody using hexagonal architecture? Okay. Just a brief introduction to what hexagonal architecture is. Hexagonal architectures allows you to write your business logic. It can be either a Spring Boot, Node.js application, Python or Flask application, and defines some abstraction on top of it. That is your main business logic. That's your domain. That's your core domain that you maintain. The abstractions are like you have the domain. Now you need ports. Ports is actually the abstraction that helps anybody can call to this domain via ports. Now, in order for anybody to access the ports, you need some adapters, right? So those adapters, right now, let's say I have a Spring Boot application running on ECS, Fargate. Right now, I have an adapter that looks at HTTP events or HTTP endpoint. So let's say you have a put request for order. It will have an HTTP adapter, and then it connects to the port. And then the business logic doesn't care whether it came from an HTTP endpoint or somewhere else. It gets a object, it does its work, returns back an object as a response, right? That abstraction, the business logic is totally abstracted from whoever is calling it. It can be HTTP endpoint today, it can be something else tomorrow. So in this case, the HTTP endpoint is a primary adapter. One of the secondary adapter can be a DynamoDB database where I want to put item, right? So I can build adapters specific to DynamoDB, which the domain underneath doesn't have to know, whether it's persisting data to DynamoDB or a relational database, etc. So that's the abstraction that you get. So your domain logic becomes very portable. I can run this in ECS today. I can move this architecture to EKS. I can move this to Lambda function, whatever, as long as my domain logic is abstracted away from whoever is accessing it. So if this is the current setup that we saw with settlement service and vendor service, I can write a new adapter for Amazon Event Bridge, putting a message or an event in SQS, and then I have an adapter that is an SQS subscriber adapter in my application without touching the business logic. I haven't touched the business logic yet. So I add an adapter, and then I have another adapter that sends an order completed event back to Event Bridge. So without changing business logic, just by adding new adapters, I'm able to make an existing containerized application who was taking care of RESTful API endpoints, make that work with event-driven setup. So now I have a event-driven application in container without making major change in my business logic. So it used to be /order put request. Now it is order created event that has changed to order completed event. Now some of the services that I use here are not the only services that you have to use. You get different varieties of services that you want to use when it comes to API, compute, event router, and event store. So with API, I chose API gateway as an example, but nothing is stopping you to use AppSync, Amazon AppSync. AWS IoT Core was the choice for me. You can very well use WebSockets to send notification. You can use, in fact, when it comes to compute, and I have used all of those computes in the sample application just to showcase that you can still do EDA with a degree of difference of varieties of compute. In my sample, I have used Amazon Event Bridge, but it is not limited to that. You can use SNS, Kinesis data streams, Amazon MSK, or Amazon MQ. The same with Event Store. I've used SQS as an example, but it is not limited to SQS. You can use the other event stores too. So if I want to summarize this real quick, EDA actually eliminates bottlenecks. What we started with the traditional architecture was bottlenecks. So EDA eliminates bottlenecks. And then we can integrate with existing workloads with very minimal change. And hexagonal architecture is one of the examples which comes up on the top. In my sample, I have used hexagonal architecture. You get fine-grained scaling. So if claims is getting a lot of traffic because of a catastrophic event, you don't want customer service to scale. You just want claim service to scale, right? So you get fine-grained scaling of components. You can extend this to different other business domains. I just talked about 4 or 5. It can go above that. And event-driven architectures, they actually facilitates evolutionary thinking, right? Evolutionary architecture. Today, we did not talk about any analytics. We did not talk about governance. We did not talk about reporting. All of those things can plug in and become a capability in your entire setup. Last but not the least, we have drastically reduced the fault impact radius. And I showed that as an example when I added vendor service, because I did not touch any other area in the system. Now think that if you are adding vendor service, you test it, and you have to broadcast or tell the entire organization that, hey, I'm going to add vendor service. It's going to be cumbersome. So this facilitates reducing your fault impact radius. Here is the QR code for the blog that I was referring to, and the sample application is also mentioned in that blog. And you can definitely play around with that. You can follow the guides, and you can run this in your own system. Additional resources to look at for building this kind of application. And then reach out to me if you have more questions. My information is right here. You can reach out to me via LinkedIn or X. And please don't forget to vote for this session.